This is a presentation on the impacts of artificial intelligence that I, Carl Seiler of PIVIT, gave at the University of Central Florida to the Department of Industrial Organizational Psychology on January 12th, 2018. For me, the AI revolution really started about 30 years ago when my cousin Henry stood in my driveway waving a research paper he had found on AI. We had both worked together on some big projects, the first space shuttle launch and coding up a nuclear power plant control rooms after the 3 Mile Island incident. We wanted to not work on big projects and do our own thing. And so, a bunch of nights and weekends, we coded up this AI algorithm for an inference engine expert system. We got it running on some early small personal computers as opposed to mainframes, which is where AI was running at the time. And we placed a small ad in a few computer magazines for an everyman's $95 AI tool. We sold a lot of copies. We sold 30,000 copies. And bam, so we launched a company called Level 5, and 3 years later we sold it to a big software firm. And I've been involved in the commercial launch of a whole bunch of software product lines, like 7 of them. And they all did okay in the market, but now I think we're finally seeing AI really break out. So I'm going to talk about kind of the how and the why and what to expect. So, for a broader historical context, you just so happen to live in a time unlike any other time in the history of innovation. It's bigger than the Renaissance, than the Industrial Revolution, and than electrification. It includes the computer revolution, the internet revolution, the Internet of Things, big data, cloud computing, CRISPR, autonomous vehicles, commercialization of space, and the AI breakout. You live in that vertical line to the far right where change happens virtually overnight. So here's a chart I like to use. It's the S-curve of the business life cycle of technical innovation and change. There's, in the beginning, a lot of attempts and failures, fast failures, and then bam, we hit an inflection where things start to get easy enough, powerful enough, cost-effective enough, and we go through an expansion phase, which moves to a maturity phase where most of the market is saturated. My own AI story speaks to this S-curve of technical adoption. We tried, we made some progress, but we never really broke out into widespread adoption. The problem with expert systems, they were coded via logical rules of symbolic expression. They were hard to write. They needed an expert's time, and the solutions tended to be brittle, unique, transient. We never really hit that inflection point. Here's some examples of S-curve breakouts. Horses transitioning cars, a 15-year transition. Black and white TV to color TV dominance, a 10-year transition. Landlines to cell phone dominance was merely a 5-year transition. And we're currently in the inflection of things like the gas car transitioning to the electric vehicle dominance, and that's going to happen fast now. Say oil industry versus solar. Photovoltaics went through grid parity with natural gas in 2016 and is still headed steeply downward in terms of its costs. And so one of the common venture capitalist views is that AI has passed through this inflection and it's time to pour on the rocket fuel. I like to quote Andrew Ng here at Stanford, who characterizes AI as the new electricity. So here's some examples of other S-curves that you've experienced in your own life. Mobile users being the curve in light blue, smartphone users use, iOS and Android use in the dark blue, and you can see the use of personal computers kind of saturating the market and topping out. So let's talk about artificial intelligence and where we're at. AI has always been kind of a difficult term, inherently confusing. My first company's t-shirt said, "The only thing artificial about me is my intelligence." We thought that was hilarious. Think of AI as algorithms that try to mimic the results of thought, software that attempts smart. Smart software really has been here for a while and is a big part of all of our futures. Looking at history, we non-human animals have always created tools and machines to make our life easier and better, that make our bodies and minds stronger. We create tools that amplify our human capabilities. This process got us out of the cave, from behind the plow, out of the factory, and soon out of the office. We seek to automate drudgery and repetitive tasks. This tends to free time for more valuable and more fun things. So why not assume, in looking forward, that this is what we will continue to do with the new tools of intelligent software? How big a deal is this for us? The best word for me is disruption, spanning major industry sectors, how our world economy functions, and how the gears of our society turns. So AI is not in some distant future. It's here and now and has been for a while, and you use it every day. AI recommends products. It recommends your music. It helps you search. It trades on the market. It builds your stuff. It's on your wrist. It's starting to drive. It fights your battles. It reviews your taxes, calculates your credit risk. Today, there are over 7,500 projects in Google using AI deep learning right now. Google's starting to call itself an AI-driven company versus a data-driven company. AI is being built from the silicon up using GPUs, graphic processing units invented for the gamers, and TPUs, TensorFlow processing units for scalable cloud-based AI apps. We are seeing a chipset race to create special processors that algorithmically mimic neurological functions. So the near-term impact and scale, here's where Gartner predicts. By 2020, we'll see $200 billion in new AI-based revenue, but it eliminates some 943,000 jobs, although it also claims that that will be counterbalanced by the creation of some 768,000 new AI-related positions. The plus and the minus implies a huge need to transition skills. By 2030, as many as 800 million workers worldwide may lose their jobs to robots and automation. This is equivalent to more than a fifth of today's global workforce. Clamp down on immigration, not enough farm workers, farmers are turning to robots. Rapid reskilling will become the key to avoiding a collapse in earnings and the ability for a consumer-driven economy to function up the ladder of the conventional job hierarchy, displacing manual labor, displacing the thought workers, displacing the bosses, and soon it will be sitting on the board of directors. The AI breakout is driven by three big changes. Number one, cheaper compute power on the Moore's Law curve. Number two, access to enough data, rich enough data, what I call long vector data, data with a lot of attribution. And number three, better algorithms such as the deep learning neural nets. We're moving from programming computers to showing stuff to computers who then self-generate the solutions and applications. Machine learning is the focus of most of the AI breakout that we're witnessing. So who has not used an auto translator or talked to their phone or seen face recognition of images on their Google Photos, or gotten a personalized video recommendation, or used adaptive speed control or lane minders in their new cars? Or who doesn't have a robotic vacuum cleaner, or talked to their lights, or talked to chat box, or been told a joke by their computers? So the sweep is broad. Machine learning is the catalyst of this AI breakout. It's been around since the 1950s, but recently started to show impressive results. ML can be decomposed into unsupervised, supervised, and reinforcement learning. Unsupervised, where the data itself provides enough information to identify a cluster, a best path, a new meaningful representation, a detectable anomaly. Supervised, where we have a human, an expert, a curator in the loop providing guidance and feedback to the emerging model and its consumed training sets. And reinforcement is where repetition and interaction with the real world provides the feedback that guides the model to converge on a good enough solution. More specifically, in machine learning, the biggest breakthroughs have come from deep learning. In deep learning, the features and clusters are discovered by the network. It's been achieving better than human expert performance. It's consuming very large corpuses of information and auto-deriving the classifiers and pattern recognizers. Not to say that most predictive models come for free. There is still considerable effort and expertise required to generate the models that converge on a good enough solutions, but that effort is largely data science, algorithm selection, tuning, and data wrangling. The key in modern ML via deep learning is that non-experts with access to big data sets, cheap cloud compute resources, and deep learning model builders can produce predictors that beat human experts. So how does deep learning work? Here's an example where we have an image in and a question we want to answer of whether it's a dog or a cat in that image. So at the very base layer, an image really consists of a matrix of red, blue, and green pixel intensity values. A neural network node at the lowest layer can be trained to have the discrimination as to whether a cluster of pixels represents something like an edge. Another layer up, that node can be trained to determine from the output of the lower layer if a collection of edges represents a shape. Another layer up may determine that that shape is an animal, and so on until the top layer classify and generate a probability scalar result that the image contains a dog and therefore not a cat. Each node gets many inputs in, runs a tuned algorithm, and generates a single scalar value out. Machine learning training is tuning of these algorithms and their weights to converge on answers that mirror a training set. The machine learning model building cycle is about building models that predict outcomes given data. The key is having enough of the right kind of data. So for example, here's a cycle. Some historical reference set is split 80-20 randomly for training data versus test set data. The test set data is set aside. A model selected and tuned using data science and training algorithms, creating a tuned model. Real incident data is run through that model. Results are predicted. Results are measured against the test data for quality. New model weights are adjusted. The model is updated. Testing and model tuning cycles repeat until a good enough solution is reached. The key to creating a deep learning neural net is to not overtrain or overfit. Otherwise, it can become brittle. Overfitting is using too many nodes. It becomes trained too closely to match the results of only the training data. You want to generate a predictive model with the least number of nodes possible to achieve a generalized solution that can mitigate ambiguities in the data. So here's an example of the different neural network types and associated applications. For example, a one-to-one topology, an image in, and a classification of that image out. A one-to-many topology, an image in, and a multi-word sentence caption out. A many-to-one, a tweet in, and a sentiment of that tweet out. A many-to-many, an English sentence in and a French sentence out. A many-to-many, a video clip in where each frame is part of a sequence and the metadata for that clip and each clip out. So what we want AI to give us are general capabilities. We tend to want Robbie the robot, who can do the dishes, drive us around, walk the dog, stitch up your cut, be your lawyer, and babysit the kids. However, what we can do today is only deep and narrow. It does one thing really well and better than you. Plays Jeopardy, chess, and Go better than humans. Reads MRIs and X-rays better than the doctors. We get a smart washing machine. Smart machines that see patterns we miss, optimize their behavior better and faster than us, and behave consistently and do not sleep. For example, dermatologists make a lot of money and take many years to train to be good. A couple of non-medical computer science graduate students in a class at Stanford used deep learning neural nets and a big bunch of curated skin disease images, and their model matched and in some cases surpassed the top 3 dermatologists in the world. So the moral here is that non-experts using some new flint knives and bearskin tools were able to better world-class expertise. So why is this not already on your phone, this kind of dermatology app? Well, taking pictures of every funny bump on your skin would be great, but it's not ready yet. It's not approved. It's not situated in some treatment protocol, but it is coming. And it's also important to note that this same app will not drive your car or do your dishes. So what patterns can we detect today? Basically, image classification, customer intent and sentiment, customer churn, autonomous navigation on the ground and in the air or on the battlefield, and the ability to discover new relationships in the data, the unknown unknowns. A breakdown of our near-term capabilities include: you can achieve better results to the questions you have now, and now you have the ability to ask new kinds of questions, and you can now consume and use data that computers could not utilize before: speech, images, video, and unstructured text. Remember, 80% of the data that we have and generate is unstructured. So pull back and we can see what's commercially available. Things like image processing and text and language processing are ready for prime time. We use Alexa, we use Hey Google, we use Siri. Image processing uses things called CNNs, convolutional neural nets, that can break down an image into components. RNNs are recurrent neural nets that are used to detect features and classify from sequences of things, like sequences of images, sequences of words, sequences of sounds. Approaching commercialization are question and answer engines, trainable chatbots, best path services, biomimicry, and robots, and that is robots learning by watching us. Not ready yet, but proving to be powerful, are adversarial and reinforcement learning systems. Adversarial training pits one learning model against another, one model trying to find the right answers in the data, and its adversary trying to spoof or fool the learner by injecting noise and errors in the learning sets. This iterates until converging on a more hardened, safer from hackability, and more robustly trained generalized model. In reinforcement, the focus is on online performance, which involves finding a balance between exploiting the world and the exploration of that world. A machine experimentally learns how to pick up, for example, a strange new object. AI and machine learning services are commoditized now as building block capabilities that are hosted by the cloud service providers. The intent is that they get integrated into all next-gen applications. This accelerates the cost-effective adoption of AI machine learning into any and all automated solutions. Three major technology surges synergistically combine and cross-support each other for a greater impact. The Internet of Things senses. Billions of sensing devices blanket the planet and connect to the Internet. The Internet of Things saves its data streams to in-cloud big data. Big data is our collective memory. It's the resource we mine and learn from, and it is the stream of now that we react to. And AI and machine learning eat big data and learn, converging on good enough predictive models. Models detect patterns. Cognitive services think, predict, decide, and act. AI talks back to IoT, closing the loop, sending commands to turn left or buy that stock or send you a hint. Slow reaction cycles through the cloud, and fast reaction cycles happen at the edge by the swarm, sometimes called fog computing. So how big is the bang? We're talking 50 billion internet-connected devices by 2020. We're already at 10 billion today. 2 trillion in the smart industrial market, 500 billion per year in the driverless market, 6 trillion on smart things in 5 years, 1 trillion on our smarter cities, 15 billion on the smart home, 2 trillion per year in the smart factory market, 100 billion per year in the smart office market. Governments care because they're hoping to improve the quality of life of their citizens. Businesses care, shooting to lower cost, increase output, and open new markets. So let's talk about transportation. It's a major industry sector, a $14 trillion sector that's in a huge change. When we think about driving, people drive differently in Boston than they do in New York than they do in Montana. They drive much differently in Mumbai. They drive differently during the time of day, night versus dark, the type of day, rainy versus not rainy, Saturday versus Sunday. Each one of those things need to be trained. We need a model that accommodates that. Biomimicry is one of the approaches to that kind of training, wherein we watch how humans drive under these different conditions and automatically generate models. eVTOLs are coming, electric vertical takeoff and landing vehicles. This bypasses our road infrastructure altogether. It's big drones carrying people. It's not a joke. And when we think about how cars sense or how vehicles sense, there's the onboard sensors, which get you out to about 50 or 100 yards. And then there's the collection of cars or vehicles that are moving together that can be thought of as a swarm. And that shared consensus understanding of the environment can extend the sensory network of the individual vehicle. And then beyond that, there's the information that's carried in the digital navigable maps at 1 centimeter resolution that gives them a broader understanding of the road ahead, the route ahead, and the traffic laws in that context. So the size of this impact is pretty significant. We think about things like insurance. If ownership shifts away, we don't own cars, we just use pay-as-you-go transportation, then why have insurance? What happens to gas stations when there's electric vehicles? Do they become charging stations? Or when you don't own the vehicle and when the vehicle's utilization exceeds 60%, you know, mostly the vehicles, when not in use and needing to be charged, they'll go to the perimeter edges of the cities to get recharged. And if you're not parking your car and it's not your car, then what happens to parking? Infrastructure itself is going to change dramatically. Intersections don't have lights. They're just air slots that you rent as you call ahead. Your vehicle calls ahead and slots itself through the intersection without any direction of travel ever stopping. So this is a major industry sector that's significantly changing. When I spoke to the people out in Wyoming who have a lot of trouble with their roads decomposing because of the harsh weather, that's what they were so interested in electric vehicle vertical takeoff and landing, is why rebuild the roads when we can just build a point-to-point pad. So healthcare is another major industry sector that's going through a big transition. I was invited to a Future Tech conference hosted by the governor of Wyoming, and it was just after I had gone through Hurricane Irma. Wyoming, I come to find out, has a billion-dollar war chest, and their problems stem from a small remote population, largely rural population. My problem after hurricane was that I was disconnected from information. I felt small, powerless, remote, and blind. I did not have access to what I needed or another way than manual means to find the things that I wanted, such as I had to drive around using up my limited gas to find gas. Really what I wanted was long-range, low-power, reliable connectivity, and someone on the other side in the cloud as an avatar who knew my resource situation and knew what my resource needs were and was trying to give me advice on where to go. I just needed a little text in and a little text out. So there's kind of a parallel between that, what I call being small and remote. The problem with Wyoming was trying to get advanced healthcare out to this rural and distributed population without having them try and move to the centers and the hubs, is bringing advanced healthcare to them. Advances in miniaturization, batteries, low-power sensors are leading to a whole family of insitables in your blood, in your intestinal tract, in your eyes, in your teeth, in your bones. And machine learning models can now monitor and predict remission and relapse in cancer patients. armband motion sensors and facial recognition can detect and predict the onset of depression. We are moving towards robotized exoskeletons that'll help people get up and out of their wheelchairs. And we're looking towards automated and personalized wellness coaches. Our Fitbits are getting to be advisors that coach us into a better quality of life. And we'll see IoT and big data and AI enabling aging in place, which is the elderly not having to move to nursing homes and assisted living facilities. Rather, there'll be intelligence in the couch and in the mat and in the refrigerator door. The toilet will know what's going into it. The mat in front of the sink will be able to weigh people, and the mirror in the bathroom will be able to help us understand the health situation of the elderly and alert people to come and help them on an as-needed basis. And in industry, the makers of our stuff, you can bring factories back to the United States, but the manufacturing line will be manned by robots. The jobs created are to aid and maintain the bots. But we're talking about efficient cogeneration of power at facilities, fine-grained asset tracking down to the smart box that knows where it's been and what it's been exposed to, autonomous electric vehicle fleets to move the goods to market, smart integrated end-to-end supply chains, predictive maintenance for expensive equipment, more efficient, cleaner, cheaper operations, less defects, and happier customers. And then there's the city. The city becomes the smart city. Cities vie with each other. They're in competition. Mayors want their city to be the city that attracts the cleaner industry sector and the higher paid employees. Mayors gain power by piloting smart projects. A smart city offers better services, is cleaner, is safer, is more flexible, is convenient, is more entertaining, is more connected. The first wave we're going to see in smart cities is smarter streetlights, where they generate their own power, they have cameras, they're on as they need to be on. The next wave is smarter parking, before the EV revolution and driverless revolution wipes out parking altogether. And then any flat surface facing up is game for being a source for solar power, photovoltaic, co-power generation. I think Asia is the place to watch, and Europe, who are surging ahead in their efforts in the smart city arena. And then there's you. Automated bots for all the initial point of service contact touch points, avatars that monitor and defend your digital persona. By 2020, most boards will have an advisor bot on the board of directors. Intelligent advisors, trainers, assistants at work, in home and in wearables. By 2025, an average connected person anywhere in the world will interact with connected devices nearly 4,800 times a day, basically one interaction every 18 seconds. All of that which you own, save, buy, sell, and exchange will be managed via your own AI advocate. And because we know so much about you, you will be scored as to whether you are at risk, are you a civil threat, are you healthy, are you a good citizen. China is the one to watch in this arena. Lastly, we should talk about the creepy factor of AI. In my experience, there are three main camps that people fall into. Either AI kills us, AI saves us, or AI is us. In the AI kills us camp, we should think about AI like nuclear weapons, where we live on the edge of potential annihilation. This is the stuff of AI and sci-fi movies. But many very smart people say that AI must be monitored, it must be controlled, it must be contained. It must not be weaponized. It must not get self-conscious. It should be treated like nukes, where we care about AI getting into the wrong hands. Certain AI should have legitimate terms of engagement. In the AI saves us camp, it helps to bail us out. It is fundamental to solving our intractable world problems like food production, water management, alternate fuel sources, It's fundamental to our security. It's fundamental to global progress. It's fundamental to life, liberty, and health. It makes life much, much, much better. It steps in where we have skill, staff, and dangerous occupational gaps. So take Japan. They're facing a major labor shortage. It's getting worse as its population ages, and it expects that gap to be filled by automation. Lastly, AI is us. AI applications get closer and closer to us. They know us. They get inside of us. They become part of how we hear, how we think, how we see, how we feel. And or we get our mental memory persona and thought processes replicated into the machine. We drop the body and bind it to the machine. Given the exponential curves of power and performance in computing, we can converge on a place where we actually kind of go into the matrix. And is that a life as a separate consciousness, or is it a collective mind hive? So, as you can see, this debate is important, it's full of cultural change, and it's steeped in ethical ramifications. So, I would ask, what camp are you in? So, thank you very much for listening. You live in a fast changing world. My advice is to pay attention, try and keep current. Certainly, AI is overhyped, as new technologies tend to be. We're seeing a lot of overhype. I would caution against it. Look at the practical applications that are rolling out and stay current. You can always contact me or my avatar at the information on the screen. Thank you very much.